Today we will discuss a question from Competency-Focused Practice Questions given by ICSE. Question number 65. First, study the diagram. It seems that from the terminal A, two branches are taken. But in fact, one of the branches are subdivided. So effectively, there are three branches from the terminal A. Shall I draw an equivalent diagram? Here is the equivalent diagram. In this second branch, there are two resistors. One is of 2 ohm and the other is of 10 ohm. These resistors are connected in series. You know that if the resistors are connected in series, total resistance is nothing but sum of the resistances. So here this 2 ohm and 10 ohm can be replaced with a single resistance of 12 ohm. Now what is our question? The question is this: which one of the switches S1, S2 or S3 should be opened so that the total resistance is equal to 4 ohms? This resistance is there of 4 ohm. So if you open this switch S1 and this switch S2, then total resistance of the circuit will be 4 ohm. Because this 6 ohm and 12 ohm are not there in the circuit now. But the problem is that we are allowed to open only one switch. So this is not the answer. Well, now consider switch S1 is open. If switch S1 is open, what will be the total resistance? Listen. Switch S1 is open, two resistors will be there in the circuit. This 12 ohm and this 4 ohm. And you know that if switches are connected in parallel, the total resistance will be less than the least individual resistance. That means the total resistance of this 12 ohm and 4 ohm is less than 4 ohm. So that cannot be the answer. We need a 4 ohm. Okay. And then think about opening the switch 2. In this case, what are the two resistors which are in the circuit? 6 ohm and 4 ohm. That also will not be correct. The reason is that, as I told you, if a number of resistors are connected in parallel, total resistance will be less than the least individual resistance. So here 6 ohm and 4 ohm are connected in parallel. So total resistance will be less than 4 ohm. So that also cannot be the answer. Okay. Now only one chance remains. This must be the answer. Let us check it. Consider switch S3 is on. Then two resistors are there in the circuit now. This 6 ohm and this 12 ohm. So what will be the total resistance? Shall I write R total? Total resistance R total. How will you find that? Here 6 ohm and 12 ohm are connected in the parallel. If two resistors are connected in parallel, equivalent resistance is nothing but the product of the resistances divided by sum of the resistances. You know that. So the total resistance of this 6 ohm and 12 ohm is 6 into 12 divided by 6 plus 12. That is nothing but 6 into 12 divided by 18. See, this is 3, 12 by 3, that is 4. 4, that is the required value, 4. So we can respond to the question. Therefore, switch S3 must be open for a total resistance of 4. Now, let us go for the next question. Part B of the question. Here they are asking to find the switch which is to be open so that the total resistance is equal to 3 ohms. So okay, we can start with this S1. If S1 is open, two resistors are there in the circuit. This 12 ohm and this 4 ohm. They are connected in the parallel. What will be the total resistance? Then total resistance is equal to 12 into 4 divided by 12 plus 4. That means 12 into 4 divided by 12 plus 4. That is 16. This will be cancelled. Yes, 3 ohm. So what will be our response? Switch. So this is the answer. Yes or no? Now part C of the question. Part C of the question is to find the switch which is to be opened so that the current through 4 ohm resistor is 3/5 of the total current. Here for the cell potential difference is 24 volt. And please understand, since these resistors are connected in parallel, each resistor will get the same voltage. Shall I find the current through each resistor when all the switches are closed? So okay, first current through the 6 ohm resistor. 24 volt divided by 6 ohm, that is equal to 4 ampere. Current through 12 ohm resistor is 24 volt divided by 12 ohm, that is equal to 2 ampere. Current through 4 ohm resistor is 24 volt divided by 4 ohm, which is equal to 6 ampere. Okay. When all the switches are closed, what is the total current drawn from the cell? I can add it up. 4 plus 2 plus 6. That's equal to 12 ampere. But the condition given in the question is current through 4 ohm resistor. That means the 6 ampere. Current through 4 ohm resistor must be what? 3/5 of the total current drawn from the cell. 3/5 of total current when one switch is open. So if I open this switch S1, what will be the total current? If I open the switch S1, current will not flow through this 6 ohm. So total current will be 2 ampere plus 6 ampere, 8 ampere current will be drawn from here. Imagine I open this switch S2. Then what will be the total current drawn from the cell? S2 is open, no? So it will be 4 plus 6, 10 ampere current will be drawn. Suppose I opened this switch S3. Then what will be the current drawn? Current drawn will be 4 ampere plus 2 ampere, that is equal to 6 ampere current will be drawn from the cell. But this possibility cannot be our answer. We need current through 4 ohm resistor. So S3 opening cannot be the answer. So our options are either S1 or S2. When I open one of this, current flowing through this 4 ohm must be 3/5 of the total current drawn from the cell. That is the required condition. This must be equal to 3/5 of total current. That implies current through 4 ohm resistor, that already I have found. What is the value? 6 ampere. So 6 ampere must be equal to 3/5 of total current. Okay. So I total means the total current required to be drawn from the cell, so that this condition can be satisfied. So on rearranging this, I will get 5 by 3 times 6 ampere. That's equal to 10 ampere. That means when I open one of the switches, either S1 or S2, 10 ampere current must be drawn from the cell. Which is that switch you have to find. That's all. Consider S1. Then current drawn from the cell is equal to, I said like this, if S1 is opened, what is the current drawn from the cell? That will be current flowing through this 12 ohm, that is 2 ampere, and current flowing through this 4 ohm, that is 6 ampere. So 2 plus 6 is equal to 8 ampere. No, that cannot be our answer. We need a current of 10 ampere from the cell. 10 ampere current must be drawn from the cell. Here it is only 8 ampere, so that cannot be the answer. Okay. Then consider S2 is open. Then current drawn from the cell. S2 is open. Okay. So in the circuit, 6 ohm is there and 4 ohm is there. So current flowing through this 6 ohm is what is that? 4 ampere plus then this. Okay, current flowing through 4 ohm is 6 ampere. So 4 plus 6 ampere. That's equal to 10 ampere. So the condition is satisfied. So what is the answer? Switch S2 is to be open so that current through 4 ohm resistor is 3/5 of total current drawn from the cell.